Hello and welcome to this presentation on SNOMED Beginner's Guide, Terminology System Demystified. This is part of Data to Wisdom lecture series termed Vidya Episteme Sapientia, and I am your presenter, Suman Bhushan Bhattacharya. So what is SNOMED CT? What does the acronym stand for? It is systematized nomenclature of medicine clinical terms. And what is its definition? It is semantically interoperable, polyhierarchical subtype, multilexical clinical terminology. And I'll try to demystify a lot of these terms during the course of this presentation. The focus of this presentation is, however, to inform and not to instruct. This is just so that people can relate to SNOMED and understand how to work with it or how it is structured. If you really want in-depth training or understanding of SNOMED, there are other platforms available for that, and you should refer to them. So SNOMED is a terminology system. What does it mean? It codes the meaning of a term instead of the term itself. So what do we mean when it says identifies the meaning of a term? Now, before we proceed further, we must understand what exactly is a code. A code is a symbolic representation or identifier of discrete information. So let's take a clinically useful term, cholecystitis. In SNOMED, this particular term maps to this particular number, and this is called code or concept identifier. However, in SNOMED, this number does not map back to cholecystitis. It instead maps to this particular set of symbols and numbers. And this is the discrete information, which is the term's concept or meaning. So we have the clinical term as cholecystitis, the machine processable code, which is the concept identifier, and the machine interpretable meaning, which is again a set of symbols and identifiers. So what exactly is SNOMED code 765810006? What does it mean? Yes, I have already showed you, but let's go a little bit deeper. So this number, which is the concept identifier, is machine processable. I will show you how it is machine processable in a subsequent slide. This one maps to this particular set of numbers, which is machine interpretable. Now, this particular set of numbers is what the identifier is pointing or identifying. But what about the human being? And okay, the machine can understand all that set of what looks like quite a complicated set of arrangements of symbols and numbers, but how is a human being supposed to make any sense of it? So there has to be some human readable description of the meaning. This incidentally is cholecystitis, which is followed by the word disorder within parenthesis and added as a suffix. And this is the fully specified name. So we might say in a way that concept identifier for the machine, it identifies the machine interpretable that thing. But for the human, it identifies cholecystitis disorder. because cholecystitis disorder is the human readable description of the meaning which is that represented by that set of special symbols and numbers. Fully specified name is also commonly referred to by its acronym FSN. So I told you machine processable. So that number is machine processable. So this is the number. Now watch. The last number is 6, which I have highlighted in red. This particular is actually a check digit. And this check digit is generated by using Varov's dihedral D5 algorithm on the numbers which are located to the left of it. You can try it out yourself. You can Google for a site where you can calculate or compute the Varov's dihedral D5, and you can put in those numbers up to 00. So 7658100, and you should get the number 6. Now the presence of check digit definitely helps, because the machine can then, without requiring any additional programming, be able to figure out whether it has received the entire number or not, or is it truncated in any way. This is always an issue, because whenever we are exchanging information, which is basically a set of numbers, we need to know that all the numbers have been correctly exchanged intact. So now this is all the machine is doing, all these things. So we have got the number, so we had a name, clinically useful term, we put it into a number, and then we got its corresponding meaning, and that meaning could also be read by a human being. Yes, but what or how would a human actually use this entire system? So we have that number again, and we bring back the cholecystitis disorder, which is the human readable aspects. So I'm out, other than the number, that the concept identifier, I will not be using any thing that is not readable by humans. So that is because here I'm going to concentrate only on how the human is going to work with it. So therefore, this is the meaning, and it is the fully specified name. Now the identifying aspect or of the FSN is the presence of something called the semantic tag, which is again in the parenthesis. Now in this case, it is the disorder. The word disorder is the semantic tag. And why do we use the word? Why do we need to have this? This particular is because it is used to disambiguate between terms with identical spellings or homonyms or acronyms. For example, cold. Now cold could be common cold. It could also be cold sensation quality. Now if for any reason it is not correctly mapped within the system, the user enters something which wants to record something, but because of the wrong mapping, it ends up being interpreted as something else. Same case with hematoma. This is even more complicated, because at least in cold, common cold sensation, so you can say that the phrases are a little different, so we can try and search for them, etc., etc. But what about hematoma? Exactly same spelling, but two completely different meanings. One is a disease, another is a cellular level changes. So whenever designing systems using SNOMED, it has to be very carefully done. All right, so this is what the number means. But what about the user? How is the user going to use this particular number within the system? This number is tagged to the word cholecystitis, the clinically useful term. Here I must add that usually the fully specified name is something that doctors can understand or care professionals can understand. But the rule is the fully specified name must be simple description of the meaning and therefore is not necessarily clinician friendly. However, every other term like cholecystitis, which is classified as a synonym, must be, so any name, any description, not a name but a description other than the fully specified name attached to a number must be or should ideally be clinician friendly. The rule is that the term must mean that meaning of that is pointed by that identifier, which in this case, as far as the human is concerned, is cholecystitis. So anything that means cholecystitis, which is a disorder, you can write that name and safely attach it to this number, and the machine would be able to interpret it without any problem. So cholecystitis synonym, and it is preferred in English. This term is also a synonym and it is preferred in Spanish. This term is also a synonym and is preferred in French. And this term is also a synonym and it is preferred in Swedish. And I have taken them all from official releases available. Now supposing you want to add something, let's say, I don't know, maybe you are interested in Klingon. So you have a term for which means cholecystitis in Klingon, you can add, it would have that particular concept identifier. No problem. You write in Klingon, the machine will still be able to interpret it. No problem. And I think you are now beginning to see the power of SNOMED. So we have cholecystitis and we have come to this particular set of numbers. Now, how do we get from cholecystitis to this set of numbers? I mean, it's not been conjured out of some thin air. There is a well-defined process for this. So the process is as follows. Some human author would be writing the term's meaning, which is always necessarily true. That is how the human author must first describe or define the term's meaning. This is then set as a set of interrelated name is equal to value pairs. This is then, this set of interrelated name value pairs are encoded using predefined concept identifiers. This set of encoded predefined concept identifiers becomes the encoded form of the definition, which is then assigned a unique identifier. Now here, it is important to mention that that meaning of a term must be unique. So you cannot have two meanings of a term. It must have only one and one meaning only. And that must be assigned a unique identifier. So the identifier will be unique and the meaning will also be unique. You are free to attach any synonym in any language, dialect, script, no problem. So let us take the case of cholecystitis. So what is the always necessarily true, unambiguous, non-vague meaning? It is a disease. It is found in the gallbladder. It is an inflammatory condition. Now, all of you who are familiar with medical terms would know that any term ending with the words itis denotes that that particular term is an inflammatory condition. And no matter what, no matter when, no matter where, these statements will always be true. without exception. Cholecystitis will always mean these three sentences. So we have the three sentences, the definition has three sentences. This is then converted into name value pairs. So we can say, this is linguistics of course, but is A equal to disease found in gallbladder, has features of inflammation. We are still working only with English. We have not gone to anything else. However, now we do the encoding as name value pairs again, you can see, but every single name and value, with the first part being on the left of the equal to sign is the name and the right side is the value, corresponding value. Each of them have their own concept identifiers, which means, and the rule is that it must be pre-existing. Consequently, each of those name values are now converted into concept identifiers of their own, which means, remember, the rule is that all concept identifiers will have an attached meaning. Therefore, each of these, like is a, what does is a mean? What does word disease mean? What does finding site, gallbladder structure, associated morphology, inflammatory morphology, what do these terms mean? The machine already has this pre-recorded, or you might say predefined and made available to it. So for the machine to unravel the meaning of cholecystitis is no challenge at all. This of course is given a unique identifier, which is this number. So we can say the definition of cholecystitis is stated as, it is human readable clinical term cholecystitis. This is the number, which is machine processable concept identifier, and this is the machine interpretable concept definition. Now, if you will recall, this number, the single identifier, identifies this meaning. This is the definition. Those disease, finding site, associated morphology. So you can see these are there. It's available over here. However, if you will recall from an earlier slide, the meaning actually had a much more set of numbers. There's some similarities, of course, between the curly brackets, but the first two numbers, instead of just one number, we have got two. So what's going on here? How are these two coming? Okay, we can understand how the left has come, but how does the right come about? No, somebody did not just imagine again. There is a process. The first one being called stated meaning, and the other one is called inferred meaning. How do we get from the stated meaning to the inferred meaning? Let's look at it. So we have the human author defining the meaning, set of three sentences, name value pairs, encoding done. It is put it into this particular format with special characters and symbols. This is the human authored stated relationship. Then we put it through a description logic classifier reasoner. So this is a computer engine. Once you subject the stated relationship to this particular type of reasoner, you get this particular set of numbers generated. This is machine generated inferred relationship. So it is the description logic classifier infers from the human authored stated relationship the detailed relationship, and it is this inferred relationship that the system needs to use. And as you will see in a subsequent slide, that it is far more detailed. I can tell you right now, on the stated relationship, if the first one said that it is a disease, the second one says it is not just disease, but it's actually cholangitis and disorder of gallbladder. We will see that, which of course means the word disease is a very broad term, but definitely when we talk about cholangitis or disorder of gallbladder, we as human beings we automatically understand what it means. And because again cholangitis will have its own definition, unique definition, and disorder of gallbladder will have its own unique definition, the machine will be able to understand what you're trying to say or what it means. So we have got this number. Now this is one of the recommended formats from SNOMED International. It makes perfect sense that we have the machine processable number identifier and we have the human readable component. So we really don't have to keep on hunting as to what this number means, and definitely you shouldn't even think of memorizing this. In fact, somewhere I have this belief that these numbers have been made a bit complicated. We will see in a subsequent lectures how this number is actually designed, but they are between 6 to 18 digits long. So it's just not possible for humans beyond a certain fixed number of concept identifiers to memorize them. And in fact, you shouldn't. The humans should only be working with synonyms. Only synonyms, not FSNs. FSN is what guys like me or clinical analysts or any other people who work with identifiers, because there is some requirement. Users may also require, but then we will see how when they need to do the queries, we are getting to that level or that level of sophistication where a user should be able to write in natural terms using natural language what they want to query, and the machine will be able to interpret it from there on. So they wouldn't be looking at any specific drop-down lists either, but we are still getting there. It will happen very soon. It's not, that day is not far away. Now this particular concept identifier is, this is the meaning, which is again in the set, and I have used the same format as above in the as for the identifier, where I have got the cholangitis, disorder of gallbladder, and if you will recall, the within the brackets, curly brackets, we have exactly the same pairs. Now the first two, which is preceded by a 3 equal to sign, there could be a different sign also, but we will not discuss this. It is out of scope for this particular presentation. The first two are what are called subtype relationships, and whatever that is there within the curly brackets are called attribute relationships. So there are two broad types of relationships in SNOMED. One is subtype, the other is attribute. This set of relationships is what causes the magic. So there is a subtype relationship. So we'll start with, we'll work with again cholecystitis, and we have seen cholangitis and disorder of gallbladder. These two again are subtypes of disorder of biliary tract, and you yourself can figure it out. Yes, it is correct that both cholangitis and disorder of gallbladder are a type of, a refinement or a finer version of disorder of biliary tract, which itself is a finer version, finer representation of finding of biliary tract and disorder of liver and by your biliary tract. Incidentally, these are easy relationship, and we have acute cholecystitis and chronic cholecystitis to be subtypes of cholecystitis. And we have it goes from finer at the bottom to coarser at the top. And you can just imagine the entire thing ultimately leads to one root concept, which is SNOMED city concept, the concept of SNOMED city concept itself. This makes, because they are all related to each other, every concept within SNOMED city is a SNOMED city concept. Specifically for this one, if we were to now focus, instead of cholecystitis, let's focus on cholangitis and disorder of gallbladder. For these two, disorder of biliary tract is its supertype parent, and finding of biliary tract and disorder of liver and or biliary tract, which are parents of disorder of biliary tract, are its supertype ancestors. Now, for these two, cholangitis and disorder of gallbladder, cholecystitis is its subtype child, and cholecystitis itself has two children. It has much more, but here I have, for simplicity's sake, I've only used two. For cholangitis and disorder of gallbladder, acute cholecystitis and chronic cholecystitis are subtype descendants. Now, if you were to look at this particular structure, it is a polyhierarchy. This is where the subtype polyhierarchical structure comes for SNOMED. It is that this is a subtype imparts that structure. And because of this structure, we can use just one command. We can make it more complex, but we can just ideally, even just through one command, we can find out a host of information. Let's say you want to find out that all records containing concepts or terms, because terms are mapped to concepts. Find me all records which have items that are finding of biliary tract, and just through one command it will be able to pick up all types of whatever that is there in the subtype descendant hierarchy, every single term, just one command. The other type of relationships are attribute relationships. So cholecystitis has two. Finding site is gallbladder, and associated morphology is inflammatory morphology. Now, because each of them have their own unique definition, so therefore, if you were to now give a different condition, let's say you ask the system to find all records that have a disorder where the finding site is belonging to the biliary tract, or maybe liver and biliary tract. Let's say it will pick up all that are subtypes of the biliary tract and all conditions which satisfied, which would include cholecystitis, acute cholecystitis, chronic cholecystitis, etc., etc., etc. Very, very easy, and this is all done in real time by the machine itself. It doesn't need any additional programming to make all these connections. Those connections are pre-made. To summarize, SNOMED city is machine processable and machine interpretable. It goes on the principle of one code for one meaning, non-vague, one meaning for one code, unambiguous. The meanings are made up of relationships that make it powerful. The meanings are encoded with pre-existing codes that have their own meanings. The subtype relationships imparts the polyhierarchical structure. The attribute relationships help make meanings detailed. Any term in any language has the same code. If you have come this far, I'm guessing you liked the video. If so, why not give it a like and share it with others? So believe me, all that I've shared over here are just the tip of SNOMED. There are other details that make it a very powerful tool in the hand of the healthcare professionals, and I plan to deal with them in my subsequent videos. The idea behind this particular lecture series is to just not SNOMED, I will also be covering other code systems, but to show how, at least for as relevant to this particular presentation, how SNOMED and other data standards can help transform healthcare, particularly clinical outcomes, leading to satisfied patients, physicians, and payers. If you have any specific requests, feel free to leave them in the comment section and I'll see what I can do. My next presentation would be a demonstration of the SNOMED browser from SNOMED International. And if you're interested to see that, why not subscribe to this channel and press the bell icon to be reminded or notified when I upload that particular presentation. So till the next time, have a great day and cheerio.